Okay, so last time we did question B first, finding the stationary points. Now we're going to look at the next bit of the question, which is actually A. So you would actually do A first. However, I wanted to do B first because I felt that that was the way that the question, if they had been a bit kinder, would have asked that one first. Okay, so let's look. So you've got the x-coordinate to the normal to the curve at P. So we know that P was this point here. Okay, so P is 3 and 5 on the graph. As I say, you don't need to draw the function because you can just figure it out using the information that you get. So when they say the normal to the curve at P, this point P, well, we know P is 3 and 5. So the normal means the perpendicular to the tangent. Okay. So what we do is we find the gradient of the tangent, and we know that perpendicular lines, when you multiply them together, -2 times 1/2 will equal -1. When perpendicular lines are multiplied together, you get -1. So in other words, if you have a line which has a gradient -2, the perpendicular line is going to have a gradient of 1/2. If it was 3/4, the perpendicular line would be equal to -4/3, right? So these perpendicular lines have reciprocal gradients. So you change you swap the denominator and the numerator, and you change the sign. Okay, so when I want the equation of the tangent to the normal, well, the normal to the tangent. Well, if this is the tangent here, then my line, my normal, is going to be then perpendicular to that. Okay, so kind of let's do it in a different color. So the normal is in green there. And they want the x coordinate, where it intersects the x-axis. So what we need to do is find the gradient. We need to find the equation of this line. And then we need to make the y equal 0 in order to find the x-intercept, because the x-intercept is here in dark blue. So that would be the x-intercept. So my steps here are find the gradient at 3. So we find the gradient at 3. Then, so that's the first thing, we find the gradient at where x is 3. That would be the gradient of the tangent, which is obviously not enough because we want the normal. So we find the reciprocal, right? So we get the reciprocal of that gradient. Okay, the way we would then find the equation of this green line is because now we have the gradient, we would then use the x values. So we'll use then 3 and 5 to find the equation of the line. Of line. And then 4 is we make y equals 0 on that line to find the x-intercept. Okay, so this is a deep question, very tricky. Now, obviously, to find the gradient, we would need to find the derivative, which we did in the last video. So I've done it here. If you're not sure, just watch the video where we did B. I'll put a link in the description. So now we're going to substitute in x into this. Okay, so -1, and we'll sub in x, which is 3, -1 to the -2 plus 9, 3 minus 5 to the -2. What does this give us, Liam? When you put this in, and I stick in 3 for this. Put it in your calculator, what do we get? Okay, so we get 2, which means the reciprocal of that gradient, so part 2 of my question says, well, therefore the gradient of the line must be 2. Sorry, negative a half, because we want the reciprocal gradient, because we're not getting the tangent, we're getting the normal to that curve. So this green line has a gradient of negative a half. And so now we simply sub in the negative a half and the 3 and the 5 to get what our C is, because remember the gradient of a straight line, y equals mx plus c. So we know the y, so that's the general form of a straight line. Your y is 5, your m is negative a half, and your x is 3 plus c. And we get c equaling, this would be 6 over 5 plus 3 over 2 would be 13 over 2. Okay, so that is our C. So the equation of the line is y equals m, which is negative a half, x plus 13 over 2. Well, we're there now, because now we simply, to find our y-intercept, we make y equals 0, x-intercept, we make y equals 0. So 0 equals negative a half x plus 13 over 2. We take the negative a half x across, it becomes a half x equals 13 over 2. We now times both sides by 2, and we get x equals 13. Our y-intercept is 13. When we look at our x-intercept is 13. So that is our answer. That is the x value of our x-intercept. We say if you wanted to, x-intercept equals 13. Let's look at our equation. Well, that makes sense right there. It's clearly 13. It should be positive. Okay, so let's look at our steps, what we did in the order. So the one was, well, the first step, if we hadn't already done it, was to find the gradient, which is to find the derivative. So that's step 1. And then we subbed in 3. So 1 was up to here, and we got 2. Now the next bit was to find the reciprocal of that gradient. So if it was 2, the perpendicular line would have a gradient of minus a half. 3 was to sub 3 and 5 into the equation. So that's what we did there. And then 4 was to make the y equals 0 to find the x-intercept. All right, so there we go. That is the question done and dusted.